Hello again. This is the second video on radicals. Multiplying and dividing radicals. I'm going to go through 3 examples, 2 of them multiplication, 1 of them division. The first one is rad 24 times rad 10. Now I know that based on the first video that I could rewrite this as rad 240, and then I can simplify rad 240 from there the same way we did in the first video, but that would be overly complicated. 240 is already broken down for us, 24 times 10, so this would kind of be like going backwards. So that is not what you want to do. You want to take what you're given and rationalize each of the rads separately to make the numbers even smaller inside the rad. So if I just look at each rad individually, that's the way to go. Rad 24 is rad 4 times 6. Rad 10 is rad 5 times 2. And since 4 is a perfect square, I can go ahead and take a 2 out of there. And then I have rad 2 times rad 6 times rad 5 times 2. And it looks like we're done, but 6 is 3 times 2, right? It's 3 times 2, and we have a 2 over here. We have a 2 over here. So we need to factor 6 as well. And we have 2 2's here, which is 2 squared. So another 2 comes out. And then the 3 and the 5, those are the only 2 values that will stay inside the radical. So I can go ahead and multiply my 2's and my 3 and 5 for rad 15. Okay, so when you're multiplying rads, it's not that different from the first video when we were simplifying rads. The only difference in this example is really we have 2 of them instead of 1 of them, like in the first video. Okay, second example. Basically the same thing, but we have numbers and variables now. Okay, so I'm going to factor the 20 and the 8, and I think I'll just leave the variables the way they are. And I'm also going to do something a little different in this one because you might prefer this way of doing it. I'm going to write everything under one rad, but factored. So 20, I'm going to change to 4 times 5. I'll leave the x. The 8, I'm going to change to 4 times 2, followed by the x squared. So maybe you like the way this looks more than having separate rads. Alright, so I have 2 4's in here. So that's 4 squared, which is 16. And I know the square root of 16 is 4, so a 4 comes out. and I'm gonna put a line through the 4s so I know that I'm done with the 4s. And there's nothing I can do with the 5 or that x or that 2, but I can simplify square root of x squared. That's just x. So x comes out and everything else stays. And I'll recombine the 5 and the 2 to make 10, followed by the x. And there we have it, 4x rad 10x. Okay, moving on to division. I have rad 6h over rad 2h cubed. Now, something that I did not mention in the first video that is foundational is this. If you have rad A over rad B, that is the same thing as rad of A over B. So that means I can change this to 1 rad with this fraction inside. And since I have that fraction, the whole fraction inside the rad, I can simplify that fraction if it's simplifiable, which it definitely is. In the rad, 6 over 2 becomes a 3, and the h over h cubed, from our laws of exponents, we know that leaves us with h squared in the denominator. Okay. Just to make things a little more clear, I'm going to rewrite this as rad of 3 times 1 over h squared. In the future, you may not need to do this, but since it's the first time, I'm going to do that here. I did that because I want you to see that the 3, of course, can't come out, and this can. Well, something can, because this is a perfect square. 1 over h squared is 1 over h. 1 over h squared is 1 over h times 1 over h, right? Okay, so the square root of 1 over h squared is 1 over h. So, continuing over here, 1 over h can come out of the rad, and the 3 stays. And using definition of division, I can put the rad 3 in the top of in the numerator and put it over the h. And there we go. Okay, so there are the basics on multiplying and dividing rads. We'll talk more about this in class together, and but definitely look at the examples in the book. I think this one is page 519, page 520. That's where the exercise is, and look at the examples before the exercise, and there'll be more examples just like this to help you understand.